For problem number 2 on worksheet 12.1 number 4, we're going to find an angle, find theta in all of these problems, but we must label our sides. So important to do that. The side across from the right angle is known as the hypotenuse. This 10 is right next to theta. This is known as the adjacent side. We're going to refer back to this wonderful little acrostic, this little mnemonic, SOHCAHTOA. If we have A and we have H, that of course means we have cosine. So I can write the cosine of theta is equal to 10 over 25. That's your adjacent over your hypotenuse. Now I'm just going to do inverse cosine of 10 over 25. And here's where we take out the calculator. Remember that we're doing inverse trig. We're hitting second cosine. You don't even have to make the fraction show up with alpha y equals. You could just hit the divide sign. And you'd get about 66.4 degrees. As we move to letter B, very similar kind of a setup. We're going to go directly across from theta. That's the opposite side. Right here, this 3 would be the adjacent side. Obviously, the hypotenuse, the longest side, the side across from 90 degrees, we don't even need to label it. We don't have a side. But you look for O and for A. That's TOA. So I'm going to write tangent of theta is equal to 8 over 3. That's your opposite over your adjacent. Just like we did in problem number 1, we're going to use inverse trig to find this angle measurement. We're going to type in the inverse tangent of 8/3. So I'll hit second tangent, 8 all over 3, and you'd get 69.4 degrees. For our last one, so we come over this way. So we look at theta. You can see as we go directly across, that's known as the opposite side. This longest side, the side across from the right angle, is the hypotenuse. Coming back to SOHCAHTOA, you can see it's SOH that we're really working with. This is the sine function. Sine is opposite over hypotenuse. It's 8 all over 10. And that means theta would be inverse sine of 8 over 10. So to wrap this up, we'll just type in second sine of 8 divided by 10. And very quickly we'll get 53.1 degrees. And that wraps up problem number 2.